In this video, I am going to solve three problems from chapter 15, Oscillations. First question. An oscillator connects to a block of mass 0.5 kilogram connected to a spring. So you have an oscillator, and this oscillator consists of a spring as well as a mass, right? And the mass is mentioned here, which is 0.5 kilogram. When you oscillate the oscillator, it will be set into vibrations. Am I right? By the time it will have the amplitude. So that means you can exactly trace its path as a sine wave. So when you oscillate the oscillator, what will happen? It will moving up and down, or either you can take the oscillator in the horizontal position. By the time if you oscillate in the frictionless surface, it will be oscillate. And when you trace its path, you can easily trace its path in the form of sine wave, right? So what they mentioned, when you oscillate the oscillator, it will have the amplitude of 35 centimeters. So amplitude is mentioned with the letter A, right? So what is the amplitude? 35 centimeter. And what is the mass of the oscillator? So the mass is mentioned here, which is 0.5 kilogram. And when the oscillator repeats its motion for every 0.35 seconds. So that means its time period is mentioned. Am I right? So what's the time period? 0.35 seconds. For every 0.35 seconds, its motions will be repeated. By using these data, we are going to find the time period. So the first question, we are going to find what is the time period. The time period already mentioned in the question. What they mentioned, its motion repeats for every 0.35 second. If its motions repeats, that means if its oscillation is repeats for every 0.35 second, means it's indirectly says it is its time period, right? So that means the motion, the oscillation, right? The motion repeats every 0.35 seconds. Am I right? They mentioned in the question. That means it says its time period is 0.35 second, right? So what is the second question? We are going to find the frequency. What is the frequency? We studied the frequency formula. Frequency is the inverse of time period. So the frequency f, which is equal to 1 over time period. And time period we already found in the first part. What is the value of the time period? The time period here they mention as 0.35 second. So once you know the time period, you can easily find its frequency. So I'm going to take the time period value, I'm going to substitute in this formula. By that, we can easily find the value of the frequency. Therefore, the frequency, which is equal to 1 over 0.35 second. What's the answer? When you divide this 1 by 0.35, you will get the frequency. So what's the answer? 1 divided by 0.350. I got 2.86. Actually 2.857 I got. So I can just round it to 2 digit. So 2.86 hertz or 1 over second. So what is the answer for the second part? The answer for the second part is the frequency. What's the time period? The time period is 0 point, because its motion, its oscillations repeats for every 0.35 seconds. That means its time period is also the same, right? Okay. What is the third question? We have to find what is its angular frequency. And we studied the relation between the linear frequency and the angular frequency in the theory. What is the rule? The angular frequency, the angular frequency, the angular frequency omega, which is equal to 2 pi f. This is the rule, right? So if you want to find the angular frequency, you simply take the frequency and substitute the value here. Therefore, omega, which is equal to 2 multiplied by pi multiplied by what is the frequency? The frequency value we got in the second part, which is 2.86, right? So what is the answer? The angular frequency omega is equal to 2 multiplied by pi multiplied by 2.86. So I got 17.969. So I'm going to round the value to 2 digit, which is 17.97. And what's the unit? The unit is rad per second. The answer for the third subdivision, right? Okay. Now we have to go to the fourth subdivision. We are going to find what is its spring constant. So generally we use the Hooke's law for finding the spring constant, am I right? But we can't use that formula here because in this chapter we studied the rule, the angular frequency rule, am I right? So for finding the value of the spring constant, we have to use the relation between the spring constant as well as the mass, right? So what's the rule? The relation connecting to the mass and the spring constant is given by the rule omega, which is equal to square root of k over m, right? This is the rule we studied in the theory. So I am going to use this equation for finding the value of spring constant. So if you want to find the value of the spring constant by using this equation, what you have to do, first of all, we have to discard this square root. So how we can avoid the square root? I am going to squaring this equation both left hand side and the right hand side. So if you square, what you will get? This, the left hand side of the equation becomes omega square, and the right hand side, when you square, this square root will be gone. So by that you will get k over m. Am I right? Where k is the spring constant, m is the mass, where omega is the angular frequency. Now I am going to rearrange this equation. Therefore, the spring constant k, which is equal to omega square multiplied by the mass. And the mass, which is already mentioned in the question, as 0.5 kilogram, and omega we already found in the previous part. What is the value of the omega? Which is 17.97. So I am going to substitute the value here. So 17.97 the whole square multiplied by the mass is mentioned, which is 0.5 kilogram. So I'm going to multiply this value. So 17.97 square multiplied by 0.5, I got the answer as 161.46. What's the value? 161.46. And what's the unit for the spring constant? The unit for the spring constant is Newton over meter. So this is the answer. So here in this question, you can't use the Hooke's law, because Hooke's law is not possible because we don't have the value of the force, everything. Am I right? So we have to write the relation connecting the spring constant and the mass related to the angular frequency, which is given by the equation omega, which is equal to square root of k over m. So by using this equation, we can easily find its spring constant, right? So this is the answer for our fourth part. So now we have to go to the fifth subdivision. What is given in the fifth subdivision? We have to find what should be the maximum speed of this oscillator. That means it has the mass, am I right? Because it is vibrating, it is oscillating. So we have to find what is its maximum speed. And in the theory, we derived the equation for finding the maximum speed, which is given by the relation the maximum speed is given by the relation v of mass, that means maximum speed, which is equal to angular frequency multiplied by xm, right? So what is this xm? Xm is nothing but its amplitude, am I right? So in the question they mentioned its amplitude is 35 centimeter. So the maximum speed we can find by using this relation V of max, which is equal to omega multiplied by xm. We have both value because in the third part, I think so, we found the value, we already found the value of the omega as 17.97, and the maximum amplitude, which is already mentioned in this question, as 35 centimeter, right? So I am going to substitute the value here. Therefore, V max, which is equal to omega value is 17.97 multiplied by the amplitude value is 35 centimeter. So I have to convert that centimeter to meter, right? So 35 multiplied by 10 power minus 2. By that, we can easily find the maximum speed, right? So 17.97 multiplied by 35 10 to the power of minus 2 is 6.29. What's the value? 6.29 meter per second. So this is the answer for our fifth subdivision, right? Okay. Now we have to go for our last question. What is mentioned in the last question? Find the magnitude of the maximum force on the block from the spring. So in this question, we can directly use our Ohm's law. What is the rule for Ohm's law? So not Ohm's law, sorry. Actually, we have to use the Hooke's law. The Hooke's law is F, which is equal to minus Kx, right? So we are going to use this formula. We are going to use that formula in this sixth subdivision for finding the maximum force on the block from the spring. So here we are not going to use the Ohm's law. We are going to use the Hooke's law. Sorry, yeah. So again, for getting the answer for the last question, which is our sixth subdivision, which is F part, for finding the maximum force is exerted when the displacement is maximum. So which rule we are going to use? F max, which is equal to minus K of X max, which is our amplitude, right? So I'm going to take only the magnitude. So if you take the magnitude of this, we can easily discard this negative because the negative of the absolute value of the negative is positive. Am I right? So I took the magnitude of the force. Therefore, F max, which is equal to Kx of m. By that, the spring constant we already found in the previous part, which is 161.46, right? So I'm going to substitute the value 161.46 multiplied by x some value is an amplitude which has the value of 5 centimeter. So 35 multiplied by 10 power minus 2, we got the maximum force. So 161.46 multiplied by 35 10 power minus 2, I got 56.51. I got 56.51. What's the unit of the force? Its unit is Newton. Clear? Clear. So in this type of questions, you should be very careful because why? We are using the answer of the first part in the second, and we are using the second part answer in the third. Like that, it is like a chain. Am I right? We are using the one answer in the second one, second answer in the third one. Like that, we are substituting. So in such a case, if you did any mistake in any one of the part, it will affect the entire answers. Clear? So you have to calculate everything properly, and most important thing, you have to keep the rule. Without rule, it is not possible, right? So this is the answer for these 6 questions. Clear? That's it.